So in previous session we started numpy, right? We wrote one or two simple programs, right? So let's create new object r1, and we want to initialize this object with zeros. Actually, we discussed this in last session also. Okay, we can use zeros method, right? So let's use that method again. Import numpy as np. Okay, import numpy library, and then create a new array, numpy array, np dot zeros, and then you can pass rows and columns. Okay, dimensions. Okay, for the matrix. So we want to create a 2 by 3 matrix. Okay, numpy array. So 2 cross 3 matrix. Run this cell and then print out R1, and R1 is 2 rows and 3 columns. So this is the 2 cross 3 matrix. So we have 2 rows and 3 columns, and all the elements are filled with 0, right? Now I'll go ahead and create another matrix. So let's name it R2, and np dot zeros. Okay, we want to create 6 by 6 matrix. Here we created 2 by 3 matrix. Okay, you can create a matrix of any dimension. So now we are going to create a matrix of 6 rows and 6 columns. Run the cell, print out R2, and see we have 6 rows and 6 columns. Okay, so 6 by 6 matrix. Right, so here we have six rows and 6 columns, and all of the elements are filled with zeros. Now we will see how we can create a numpy array and initialize all the elements with the same number. Okay, here all the elements are being initialized with 0. Okay, we are using zeros method. So every element of this array, of the 6 by 6 array, is being set to 0. So now we will see how we can create a numpy array and initialize every element with the same number. So for that, okay, we have a full method. Let's create R3 equals to np dot full. Call full method. Okay, and it takes in 2 parameters. It has 2 parameters. First parameter is the dimensions of the numpy array matrix. Okay, so you can supply the dimension of the matrix as the first parameter, and second is the value with which you want every element, okay, to be filled. Okay, the value which has to be filled inside the matrix. So here we want every element of the matrix to be filled by 5, any number. Okay, and specify the dimension of this matrix. So let's create a matrix of 3 rows 3 columns. Okay, so here first parameter is the dimension of the matrix, and second parameter is the value, okay, which we want to be filled inside the matrix. So here we are creating a 3 by 3 matrix. Run the cell, print out R3, and see now every element is set to 5. Okay, this matrix is filled with 5. So second parameter, using this second parameter, you can specify the value, okay, with which you want the every element, okay, to be set. Okay, you want the matrix to be filled with, right? So here we are passing 5, so we want every element to be filled with 5. Next, we will discuss, suppose we want to create uh, one more matrix. Okay, let's create one more matrix of different dimension, okay, and uh, set matrix to different value. So let's create a matrix of 3 by 5, and I want this matrix to be filled with 10. So here we can specify, okay, 10. Run, and now this is 3 by 5 matrix, 3 rows, 5 columns, and this matrix is filled with 10. Okay, so as you see, we have 3 by 5 matrix, and we have 3 rows, 5 columns, and all of the elements are filled with the value 10. Now we will look at the next method, arange. Okay, so arange is a method, and that is what we use when we have to initialize a numpy array with a particular range. So here I want to initialize a numpy array with a particular range. Okay, range is suppose 10 to 50. Let's create R4 equals to np dot arange. So it's a function. Okay, arange is a function. Then specify lower limit and the upper limit. So lower limit is 10, upper limit is 50. Run this cell, and then print out R4. And now we have this array, numpy array. Okay, it has 10 till 50. So here the first parameter is inclusive. So 10 is inclusive, but the second parameter is exclusive. So second parameter is 50. So 50 is not added, okay, to this array. Okay, so because second parameter or the upper limit is exclusive. So we have the values which are starting at 10 and go on till 50. So when I say go till 50, go on till 50, it will stop at 49. It will not include 50, right? If we have to give a step to it, okay, so here let's copy this, and object name is r5 np dot arange. Lower limit is 10, upper limit is suppose 100, and step is 5. Okay, now run this cell, print r5, and result is 10 to 100 in this step of 5. So if you see 10 plus this 5 becomes 15, 15 this 5 becomes 20, and this is 95. 90 plus 5 is 95, and 95 plus 5 is 100, but this upper limit is exclusive, so 100 will not be added. Okay, so now we have this array, okay, which has values starting at 10 till 100 in this step of 5. Okay, so we have given a step actually for it, okay, which is 5. Now let's create one more array, r6 np dot arange, and first parameter is 1, second parameter is 105, third parameter is 5. Okay, it means starting at 1 till 105 with this step. Okay, 5 step. Okay, numbers will be added. So let's change step to 10. Step is 10. Okay, now starting at 1 till 105 with this step, step 10. Okay, numbers will be added, okay, to this array. Run this cell. Now print out R6, and now it is, now see, 1, 11. So first number is 1, starting at 1, then 1 plus this step 10. 1 plus 10 is 11, 11 plus 10 is 21, 20 plus 10 is 31, and so on. 91 plus 10 is 101, 101 plus 10 is 111, okay, which exceeds this upper limit. So that next number not added to this array, right? So this is how, okay, you can use arange. Okay, next, suppose you want to create an array and you want to fill that array with random integers. Okay, so R7 equal to np dot random. So this random is a function, it's a method, random dot, and then call a sub method on random. Random dot call randint. Okay, randint. It takes in three parameters. First parameter is the lower limit, second parameter is the upper limit, and third parameter is the number of elements. Okay, you want to be extracted to be generated and added to this array. So lower limit is 1, upper limit is 100, and step is 10. Okay, so first we give a range. So here we are giving a range 1 to 100. So within 1 to 100 we will extract 10 random numbers. Okay, 10 random numbers. So the first parameter is the lower limit. This is the lower limit of the range. The second parameter is the upper limit of the range, and from this range the number of values you want, okay, to be extracted. So here we want 10 random integers, okay, from this range. Run this cell and print R7, and now we have this numpy array, okay, which has random values. So if you run this again, run it again, print out R7 again, and see we have now different set of values. So every time you run it, okay, you get a different set of values. Okay, if you run it one more time, print out R7, now we have different set of values. So every time we are running it, values are changing because we are using a random.randint. It means we are randomly generating values. Okay, so randomly generated values are being added to this numpy array. So if you have a requirement to create a numpy array, and if you want the array to be initialized with random numbers, okay, then you can use you can invoke random on np, invoke randint sub method on random, and pass in three parameters. First parameter is the lower limit, second parameter is the upper limit, and third parameter is the number of values, okay, to be generated, to be extracted, and to be added to this numpy array. Next, we will discuss how to join numpy arrays. So now we will work with some interesting stacking functions in numpy. Okay, so we have vstack, for vertical stacking, we have hstack for horizontal stacking, and we have column stack for column stacking. Okay, so let's create two numpy arrays. So here create n1 equals to np dot array and pass a list. So let's pass 10, 20, 30 and 40. Okay, we have created n1. Create one more numpy array, np dot array 50, 60, 70, 80. Run this cell. Okay, now we have two numpy arrays, n1 and n2. Now what we want is uh, we want to vertically stack, okay, these two numpy arrays on top of each other. So to vertically stack these two arrays, you can use np dot vstack. This is uh, used for vertical stacking, and pass the numpy arrays. So we want to stack n1 and n2. Okay, and pass these as tuple. Okay, so use parenthesis. Run this cell and see n1 and n2 are independent arrays, right? So in n1 we have 10, 20, 30, 40, and n2 we have 50, 60, 70 and 80. So np.vstack, okay, and we are passing n1 and n2 as a tuple to vstack, and now we have in this output we have these two arrays stacked vertically. So this is first array and this is second array, right? So for vertical stacking, okay, you can use vstack. Next we will discuss hstack. So hstack is used to horizontally stack numpy arrays. So let's use np dot hstack and pass a tuple. First member is n1, first element is n1, second is n2. Run this cell and now see 10, 20, 30, 40 are the elements from n1, and then 50, 60, 70 and 80 are the elements from n2. So now the elements, the n1 and n2 are stacked horizontally, right? So this is how you can stack arrays, NP arrays horizontally. Then we have the column stack. Okay, when we use column stack, the values of the first numpy array goes into the first column, and the values of the second numpy array goes into the second column. So let's use np dot column stack, and here pass n1 and n2. So we are passing n1 and n2. Run this cell, and if you see the elements of first array, 10, 20, 30, 40 are now elements of first column. 10, 20, 30, 40. Elements of second array are now elements in second column, 50, 60, 70, 80. So if you have requirement, okay, to stack multiple arrays, okay, into columns, okay, then you can use column stack. So this is how, okay, we can work with vstack, hstack and column stack. Now we will discuss intersection and difference. So now there are other interesting methods in NumPy, okay, which we can use for intersection and difference. And using these methods, okay, we can find out the common elements which are present in two NumPy arrays, or we can find out those elements which are present in one particular array but not present in the other NumPy array, right? So we have intersect and set a difference. So let's create two arrays, n1 equal to np.array, np.array, and add elements 10, 20, 30, 40, 50 and 60. Okay, 6 elements we have added to n1, this numpy array. Create one more array, n2, np.array, and pass 50, add 50, 60, 70, 80 and 90, one more element. So we have created two numpy arrays, n1 and n2, right? If you want to find out the common elements, okay, in two arrays, so here 50 and 60, 50 and 60 are common elements, right? So you can use here np dot set diff, and pass n1 and n2. Okay, so set diff will give us what? It will give us the difference, and if you want to find out the common elements, okay, you can use intersect. So np dot intersect, it will give us the common elements from both the numpy arrays. So let's run this intersect. So now see 50, 60, 50 and 60 are present in both the arrays, right? So these are the common elements. So to find out the common elements in two arrays, okay, you can use intersect, and to find out the elements which are present, okay, only in one array, okay, not in the other array. In that case, you can use set diff. So np dot set diff n1, n2, and now 10, 20, 30, 40. These are the elements which are present in n1, 10, 20, 30, 40, but not in n2, right? So if you want to find out the elements which are present in one array, not in other, okay, you can use set diff. So here it is giving us what? The set diff, we are passing n1 and n2. Okay, this is giving us the elements which are present in n1, not n2. So if you want to find out the elements which are present in n2, not in n1, you can use np dot set diff, pass n2 as first parameter, n1 as second parameter. So it will give us what? It will give us the elements which are in n2, not in n1. Run this cell, and now 70, 80, 90. So 70, yes, 70, 80, 90. These are the elements in n2 which are not available in n1. Right? So this is how you can use set diff to find out the elements which are present in one array, not in the other array, and intersect to find out the common elements. Right? Now we will discuss some numpy array mathematics. So here, suppose you have two arrays, and you want to add values of the two arrays. Okay, you want to add values of which are present in n1 and n2. So let's create two arrays, x1 np dot array, and to keep it simple, let's add 2 3 values, 10, 20 and 30. We are adding 3 numbers, right? So we have created one np array. Now x2, create one more np array, np dot array 40, 50 and 60. Okay, we have 3 elements in x2. Now to add all the values of n1 and n2, you can use np dot use sum method. Okay, and pass the elements of pass n1 and n2 and pass these two arrays in a list. Okay, we are passing n1 and n2 in square brackets. Run this cell. Where is the problem? Sorry, this is x1 x2. We passed n1 and n2. This is x1 and x2. And see, sum is 210. So 10 plus 20 is 30, 30 plus 30 is 60, 60 plus 40 is 100, 100 plus 50 is 150, 150 plus 60 is 210. Result is 210. Okay, so this 210 is the sum of all the values of x1 and x2. Instead of adding all the values, okay, if you want to add the corresponding values, it means sum of 10 plus 40, 20 plus 50 and 30 plus 60. Okay, if you want to find out the sum of the corresponding elements, okay, first element of both x1 x2, second element of both, third element of both, in that case, okay, you can use access parameter, right? Okay, if you want to add it, if you want to add corresponding values, okay, with respect to some access, you can use access parameter. So let's use np dot sum function, and the first parameter is x1 x2 and second parameter is the access. Okay, you can specify access, you can specify whether you want the corresponding elements to be added or elements of a particular array to be added. So here we want corresponding elements to be added. So we want first element of both the arrays, second element of both the arrays, third element of both the arrays to be added. Okay, so here set access to 0, otherwise set it to 1. Run this cell and now see 50, 70, 90. So 10 plus 40 is 50, 20 plus 50 is 70 and 30 plus 60 is 90. Okay, so here we are setting access to 0. Okay, so it is adding corresponding values, corresponding elements, okay, from the two arrays x1 and x2. Now instead of doing that, okay, you want to add the elements which are present in one particular numpy array itself. So we want the elements of x1 to be added, we want the elements of x2 to be added. Okay, then okay, you will set the access value to be equal to what? 1. So here what you can do is you can say np dot sum and pass x1 x2 and specify access. This time set access to 1 because we want the elements of a specific array to be added. Okay, now run this cell and see, because we have two arrays, x1 here, x1 and x2. We are working with two arrays x1 x2, so we are getting two elements in this list. So this 60 is the sum of all the elements in first array. So if you see, 10 plus 20 plus 30 is 60. So 60 is the first element in this result list. 40 plus 50 is 90 plus 60 is 150. So 150 is the second element in this list, right? So if you want all the elements of a specific array, okay, to be added, in that case you can use access and set it to 1. Now we will discuss some uh, basic, okay, math operations which you can perform on numpy array. So here we have x1. X1 has 10, 20, 33 elements, right? So let's print x1 here, okay, to confirm. Yes. So x1 is 10, 20, 30. Now, if you want to perform addition, okay, you can write here uh, x1 plus 1. It means we want to add 1 to every element of x1. So elements of x1 are 10, 20, 30. So this value will be added to every element of x1. So 10 will become 11, 20 will become 21, 30 will become 31. Okay, and result is 11, 20, 21 and 31. Okay. Now to perform subtraction, so current value of x1, current status of x1 is 10, 20, 31 because we have not modified the array. Right here we have not modified the array, we just actually added 1 to every element of this array. Now to perform subtraction, what you can do is you can use array name minus, okay, the value that you want to subtract. We want to subtract 1 or we want to subtract 2 from the every element of x1. Run this cell and see, now we have 8, 18, 28. Okay, so this 2 subtracted from 10, 20 and 30, right? And to perform multiplication, here you can write x1 into 2. Run this cell and now it is 20, 40 and 60. Okay, so 10 multiplied by 2, 20 multiplied by 2, 30 multiplied by 2. Every number, every element of this array multiplied by 2 and result is 20, 40 and 60. Okay, and similarly you can perform division. So if you want to perform division, you can write x1 divided by 2, run the cell and now we have 5, 10, 15. Okay, so this is result is the array is 10, 20, 30 and result is 5, 10, 15. Every element divided by 2. Okay, if you want to perform or if you want to find out the mean, median and standard deviation, okay, of the elements, so let's create a new array here. Let's create x2 np dot array and add few elements to it, a couple of elements. So 10, 20, 30, 40, 50 and 60. Run this cell. So we have created x2 and x2 has 10, 20, 30, 40, 50, 60. Okay, these elements, right? So x2 has these elements. Now to find out the mean, you can use np dot mean and pass the array name. Now run the cell and the mean is 35. This is the mean of this array, this collection of elements. Okay, to find out median, you can use np dot median and pass the array x2, run the cell and median is this, right? And to find out the standard deviation, okay, you can use std function. So let's call np.std, it's a function, and pass x2. Run this cell, and the standard deviation is this, right? This is standard deviation of this collection. We have, suppose you have requirement, you are working with a large volume of data, okay, you are working with numpy array which has large amount of data, okay, you want to save that data, okay, for future use. In that case, what you can do is, suppose we have this x2, okay, the current status of x2 is this, so it has 10, 20, 30, 40, 50, 60, okay, these elements. So if you have a requirement to save this collection, this numpy array, okay, in a file for future use, for future reference, you can use np dot save, the save method, right? And here you can pass the name of the file. I want to save this file with the name my numpy data, or let's call it array, my numpy array. Okay, and second parameter is the numpy array, okay, that you want to save. So we want to save x2, okay, we want to save this x2. Run this cell, okay, cell executed successfully. Now after you have saved your data in a file, okay, later on, okay, to work on this data you want to load this data again, okay, in your program. So what you can do is you can use load method. So suppose we want to load this data again, okay, so np dot load, and use this name, and this file is always saved with some extension, okay, so don't forget to use that extension. That extension is npy, numpy npy dot npy, right, and assign this to my x2. Let's name it my x2. My x2. We saved x2. Okay, now we are loading this x2 data in my x2, and we are calling np.load, passing the file name as the parameter. Run this cell, cell execute successfully, and now you can execute, you can print out my x2. So my x2, and see, now this my x2 has the elements of x2, 10, 20, 30, 40, 50, 60, right? So that's all for this session. So thank you everyone for joining today's session. Thank you.